In this video, we are going to learn how to do the inverses of cosecant, secant, and cotangent. So let's dive right in. We're going to do this just like we did for the other three. We're going to look at the triangles, we're going to look at what the function does, and then how the inverse relates to the function. All right, so you've got the 45, 45, 90 triangle on the top of your paper. Let's go ahead and write those side lengths in there. The side lengths are 1, 1, and square root of 2. That gives us the ratios that we need. So cosecant. What is the ratio for cosecant? Well, cosecant is the reciprocal of sine. So therefore, cosecant is going to be hypotenuse over opposite. So looking at this 45-degree angle here, hypotenuse over opposite. So that's going to be the square root of 2 over 1, which simplifies to be square root of 2. Okay, so look at what happens with the function cosecant. You give it an angle value, and it gives you a ratio back. Now, in this case, we could simplify the ratio to be just one number, but it did, in fact, give us a ratio here, two numbers compared by division. So every time I have an angle value as a domain for cosecant, the range value is a ratio. So inverse cosecant or arc cosecant is going to do the opposite of that. We're going to give it a ratio, which remember square root of 2 is the same thing as square root of 2 over 1, so I can easily make that look more like a ratio. And it is going to give us, as an answer, an angle. So this is really asking you what angle has a cosecant of square root of 2 or square root of 2 over 1. Well, we already know one answer to that is 45 degrees. But just like sine, cosine, and tangent, I'm going to be able to get two answers for that because cosecant is positive in two quadrants. So I've got my unit circle here. I know they're all positive here in the first quadrant. There's my 45-degree angle that I already gave as an answer. So the question is, what is the other quadrant where cosecant is positive? Well, cosecant and sine are reciprocals of one another, so therefore they are positive in the same quadrants and negative in the same quadrants. So the other angle value that I want is here. 45 degrees is my reference angle. 45 degrees from 180, 135 degrees. So the two answers that I'm going to get for cosecant, 45 degrees and 135 degrees. All right, let's do another one. Let's do secant. So I've got my 30, 60, 90 triangle here. You've got it on the top of your paper. Let's write the side lengths in there so that we can do our ratios. 1, 2, square root of 3. Okay, secant. What was the ratio for secant? All right, secant is the reciprocal of cosine. So secant is going to be hypotenuse over adjacent. So looking at my 30-degree angle right here, hypotenuse is here and adjacent is here. 2 over the square root of 3. So that's my ratio answer. However, we need to rationalize that. We have a square root here in the denominator, and we don't leave our answers like that. So let's multiply by square root of 3 over square root of 3. So 2 square root of 3 over 3 is going to be our simplified answer. So the actual ratio that we get is here, and then when we simplify it, we get this, 2 square root of 3 over 3. So the way that you're going to see this on a test or a quiz or in Delta Math or when you go to college is that it's going to have already the simplified answer here. And so this is asking us what angle has a secant of 2 square root of 3 over 3. Because remember the inverse, you give it the ratio, this one just happens to be simplified, and you get an angle answer back. All right, well I know one of them is 30 degrees. Let's put that in there. Okay, so then what is the other angle? Where else is secant positive? Well, secant goes with cosine, so it's positive here in the first and the fourth. Now, I've already got my first quadrant answer. Now I need my fourth quadrant answer. So if I go around the unit circle and I stop here with a reference angle of 30 degrees away from 360, that's going to be 330 degrees. So my two answers here, the two angles that have a secant of 2 square root of 3 over 3 are 30 and 330. All right, let's try this one. Cotangent inverse square root of 3. Okay, so let's see what we can do. You've already got the triangles on the top of your paper. You've already got the unit circle on the top of your paper. Cotangent. The ratio for cotangent, remember cotangent is the reciprocal of tangent, so the ratio for cotangent is adjacent over opposite. Look at the triangles, see if you can figure out which triangle has or which angle, I'm sorry, has a cotangent of square root of 3, which if you need to put that 1 under there so that you can see the ratio, square root of 3 over 1. All right, well, here's my triangle. Adjacent, square root of 3, and opposite of 1, that's going to be that 30-degree angle we had last time. Adjacent of square root of 3 and opposite of 1. So my first angle is going to be the same, 30 degrees. But cotangent is positive in which two quadrants? It's positive in the first and the third, just like tangent. So what's this 30-degree reference angle in the third quadrant? 30 degrees past 180, 210 degrees. So there you go. I have two angle answers, 30 degrees in the first quadrant and 210 degrees in the third quadrant. Okay, let's try again. This time let's switch and do radians. Let's practice with radians. All right, let's see what we can do. So I have some angle and its secant is negative square root of 2, which if you want to write that a little bit more obviously like a ratio, negative square root of 2 over 1. Okay, so look at the triangles in the top of your paper. See if you can identify which angle has a secant of negative square root of 2 over 1. All right, well, we can get the reference angle. So I know that my side lengths are 1, 1, square root of 2. So therefore, my reference angle is 45 degrees, hypotenuse over adjacent. But two things. Number one, I want these to be the negative values. And number two, I want them to be in radians. Okay, so let's keep our 45 degrees in mind. A couple of different ways to do this. First of all, if you don't remember which denominator goes with 45 degrees, you can always take your 45 and multiply by pi over 180. And then you'll have to simplify. 45 goes into 180 4 times. So my radian reference angle is pi over 4. Okay, so now I have the right reference angle in radians. And now the question is, which quadrants do I want to be in? In which two quadrants is secant negative? Well, secant is the reciprocal of cosine. So cosine is positive in the first and the fourth, which means it must be negative in the second and the third. So the answer that I want is the second quadrant answer that has a reference angle of pi over 4, and the third quadrant answer that has a reference angle of pi over 4. Okay, so see if you can remember about the numerator. Remember the numerator in the second quadrant is always 1 less than the denominator. So I've got 3 pi over 4. And then here in the third quadrant, the numerator is always 1 more than the denominator. So I've got 5 pi over 4. So those are my two answers, 3 pi over 4 and also 5 pi over 4. Now, I mentioned this in the last video, but I just want to remind you, if you don't yet think very well in radians, which is fine, this is brand new this year, right? For calculus, it's very important that you're able to think in radians, but this is just prepping you for that. So if you need to think in degrees for right now, that's okay. So what would this angle be in degrees? Well, it's 45 degrees away from 180, so that would be 135 degrees. And this one is 45 degrees past 180, so this one would be 225 degrees. And then to get my 3 pi over 4 and my 5 pi over 4, I can multiply by pi over 180, and then I can simplify. 45 goes into 135 3 times, 45 goes into 180 4 times, and I'm going to end up with 3 pi over 4. And I can do the same thing to get the 5 pi over 4. The important thing is at the end you have both 3 pi over 4 and 5 pi over 4, and that those of you who are preparing to take calculus are getting closer and closer to being able to think in terms of radians without having to think in degrees first, because that's going to slow you down. All right, let's try this one. What angle in radians has a cosecant of 1? Cosecant is the reciprocal of sine. So my ratio there would be 1 over 1, hypotenuse over opposite. Well, there's not any triangle where the hypotenuse and the opposite side are the same. In triangles, right triangles, the hypotenuse is always the longest side. So therefore, I know that it must be my quadrantal angles that I'm looking at. One of those or two of those must be the answer. Okay, so cosecant, reciprocal of sine. Does sine go with x or y? Well, sine goes with y. So where sine is equal to positive 1 is going to be here. In this case, sine y is 0. In this case, sine, or the y value, is also 0. And in this case, sine, or the y value, is negative 1. So in this case, we're just going to have one answer. So what is that in radians? Do you remember? How far is this in radians? Do you remember half a circle is pi? And we went half of that. So the answer is pi over 2. All right, if you're not quite ready to think in radians yet, think about it this way. A whole circle is how many degrees? 360. And I went 1/4 of a circle. 360 divided by 4 is 90 degrees. And then if I take 90 and I multiply by pi over 180 and simplify, I'm going to get pi over 2. So either way, I'm going to end up with pi over 2 as my answer. It's just that this way is a little bit more efficient, and those of you guys who are going forward to calculus need to get better and better at that. Those of you guys who are not doing calculus, it's less important. But if you're going to do calculus, it's important that you learn to start thinking this way. Okay, let's try this one. What angle has a cotangent of negative 1? So again, if I want to, I can make that 1 over 1. Okay, so cotangent. Cotangent is adjacent over opposite. So which triangle has my adjacent side and my opposite side the same? Well, that's going to be my 45, 45, 90 triangle. Having trouble scooting my little box over, goodness. There we go. All right, so let's put the side links on there. 1, 1, square root of 2. Okay, so again, I'm going to keep that 45 degrees in mind. Do you remember from last time? What was the denominator in radians when the reference angle was 45 degrees? Well, it's 4. So I know I'm going to have something with pi over 4. The question is just, what is that numerator going to be? Okay, so let's figure out what quadrants we're in. Cotangent is negative in which two quadrants? Well, it's negative here in the second and the fourth. It's positive in the first and third, negative here. So in the second quadrant, remember the numerator is 1 less than the denominator. And in the fourth quadrant, you remember how we had to do the fourth quadrant because we made it almost to 2 pi? We had to multiply by 2 and then subtract 1. 2 times 4 is 8, minus 1 is 7. So 7 pi over 4 there in the fourth quadrant. All right, let's try one more. Arc cosecant of 2, or you can say 2 over 1 if you want to. So what angle has a cosecant of 2? Hypotenuse over opposite is 2. All right, so let's see. I've got hypotenuse and I've got opposite. That's going to be my 30-degree angle. And do you remember what the denominator is with that in radians? It's a 6, because there are 6 30s in 180. I know I'm going to have two answers. Cosecant, reciprocal of sine, is positive in 2 quadrants. It is positive in the second, which means the numerator is going to be 1 less than the denominator. And it is positive in the first, which means the numerator is going to be 1. So the angle that has a cosecant of 2 is 1 pi over 6 and 5 pi over 6.